All right, so we are working today on expanding our understanding of how earthquakes operate in our planet. So, you know already in our studies of California that earthquakes happen when there's movement along the fault line. And of course, fault lines can happen anywhere, but they're more likely to happen at transform plate boundaries. So, when you think back, transform, does that mean the plates push, pull away, or slide by? The right answer to that is that transform boundaries like California are a slide by. So you're likely to get movement on fault lines there. And so what we want to study now is how does energy from an earthquake actually travel? And you'll be using this presentation to complete your notes. And we're going to apply this to an exciting topic, which is locating the epicenter of an earthquake, meaning the starting point. And you're actually going to do the work of earthquake scientists with our next step. So here's the deal. When I say sound and light, back to sixth grade, and I would ask you, well, how does the energy from sound and light travel? You would probably say, oh, sound and light, that travels in waves. It's no different for earthquakes. Your first fill in there, I want you to put seismic waves. Now, I bet some of you have heard of this, but here's where it gets tricky. If this lesson was just, oh, energy travels from earthquakes and seismic waves, it would be done. But here's the problem. Seismic waves come in different varieties, and the different varieties are important for different reasons. So we need to really break that down. So question 2, here are the two types of seismic waves, surface and body waves. So if you look at my arm as the surface, say at Point Reyes where the fence line got cut in half, under here might be where the San Andreas Fault moved. So seismic waves travel in all directions from the earthquake. Some of them travel up. Those are called surface waves. Some of them travel out in all directions. Sorry about that, excuse me. Some of them travel out in all directions, and those are called body waves, okay? So here's what we have so far. All energy travels from the fault line in the form of seismic waves, but seismic waves are different. The ones that head to the surface are called surface waves. The ones that stay inside the earth are called body waves. Now, question 3, surface waves are the ones that are to be worried about because they actually do damage on the surface. And then body waves travel inside the earth. That actually does not need to be capitalized for yours because it's in the middle of the sentence. They stay inside, so they're not even in the right place to do the damage. Now it gets even trickier. Here's why I say that. Because the body waves that stay inside the earth that travel in all directions, they actually come in two types, which are called primary and secondary. And primary and secondary seismic waves have two important differences. So if you check this out with me, the first important difference is the speed difference. Primary seismic waves go faster than secondary seismic waves. And also, P waves or primary seismic waves can travel through any layer, where S waves can only go through solid. So what that means is S waves can go through the solid lithosphere. They disappear from seismogram records in the jelly-like asthenosphere, reappear in the solid mesosphere, disappear in the liquid inner core, the liquid outer core, and reappear in the solid inner core. So now I had a student years ago say, I remember it as SSS. And I said, what? And she said, I remember S waves are slow and only through solids. So if you can think S, slow, solids, you've got that down. Now, number 7 is an important one for the lesson that's coming next. We use this speed difference to find where the earthquake started, and that's called the epicenter. Now, I know not everyone's mind works the same way, but I really like this. And I did not have you put this into your packet, although some of you may want to use it more for your studies. The way that I did this is through a concept map. So I, in my mind, can split it. Okay, seismic waves, body and surface. Then body waves get split into two categories, primary and secondary, which is really abbreviated PNS waves. That's not just a Mrs. Figgis special. Now, sometimes students will ask, should we be afraid of those primary waves? And the answer is no. The primary waves don't even head up to the surface to do the damage. So when you look at this, you can see PNS waves are actually helpful in finding the epicenter, but they stay in the interior of the earth and don't even do damage on the surface. So we will build on all this with our locating the epicenter activity coming next.